Good day, geometry. It is day 2 of writing proofs. We're going to pretty much do the same thing we did yesterday in the sense that we're just going to go about this. There are multiple paths to get to the ending proving statement. We're going to try and stick together, though, just so that we can all kind of have the same steps, same logic. We can be hearing the same things. The thing I'm going to add from yesterday is that if you have a question, do not wait until the end of the proof to tell me that you are lost. Tell me immediately, okay? Let that be a life lesson for you. When you're out driving around trying to find some place and you realize that you're lost, don't just keep driving, okay? You'll get further away from where you actually want to be. Stop, get directions, get help, okay? Don't just keep going. So, immediately, if you get lost, stop me. Okay, there's a hand up over here. Does someone have a question? No? Doing the one in the top right here, we are given that angle ABD is a right angle, and we're given that CBE is a right angle. Okay, so again here's ABD. I'll kind of underline that and highlight that in green. And then CBE is this one here. And we know that both of them are right angles. And our job is to prove that angle ABC is congruent to angle DBE. So remember now, we're starting with what do we know? Okay, every single proof starts with what is given. Okay, what we know. Then we want to write what we can conclude based off of that. And we talked yesterday about our proving statement involves angles ABC and DBE. That means we've got to invite them to the party, right? We have to bring them into the proof some way, somehow. So our goal should be, what do we know, right? Start with that. Then how can we introduce ABC and DBE into the proof some way, somehow? Okay. So step number 1, I'm going to leave lots of space for my statements today. Yesterday I got kind of squished. So I'm going to kind of put it over here and really give myself lots of room to write. Step number 1, angle ABD is a right angle. And in that same step, because it's part of the given statement, CBE is a right angle. Okay? And both of those can be covered under the same reason, which is that's what's given. Right? Start with what is given. Okay? Now, what can we conclude? We've started with what we know. What can we conclude? And let's not introduce ABC and DBE yet. Okay, there is something that we should establish first. Ellen? And how do you know?
Because they're both 90 degrees in a right angle.
Yes, and what theorem tells us that right angles are congruent?
I don't know.
Kylie? The right angles congruence theorem, okay? Because they are both right angles, step 2 can be that angle ABD is congruent to angle CBE. Okay, and we know that because of the right angle congruence theorem. Okay? If you want to put the RACT, okay, but again, remember, you got to know what that stands for when you look back on it later on. But it's the right angle congruence theorem. Okay, so now we've established that. Okay, let's bring in ABC and DBE. How can we introduce angles ABC and DBE? Aiden, what's your thought?
Angle ABC is half of angle ABD.
How do we know that?
Because of the angle bisector.
Is there any information that tells us either the measures of angles ABC or an angle bisector is present? Is there any way that you can say that's an angle bisector? Because the angle bisector theorem tells us an angle bisector will divide an angle into 2 congruent parts, but is there any indication that it does? No. So we can't use that. Okay? We would have to have something about, those 2 angles are congruent or given to angle measures or something like that. Okay? Another option. Max, what do you think?
Say like angle ABC is part of like the ABD of 90 degrees.
Okay, ABC is a part of the angle ABD. So let's kind of work with that a little bit. what can we say about ABC that we know to be true? Maybe it is an angle bisector, right? We don't know that, but what can we say about ABC that we know to be true? It is a part, but that's not really a math postulate or theorem. Bryn, what was your thought?
Angle ABC plus angle CBD equals angle ABC.
All right. Step 3. ABD is equal to the sum of angle ABC and CBD. Okay? Angle ABD is the sum of angle ABC, which is this top angle here, right? And plus CBD, bottom angle. Okay? Catherine? Angle addition postulate, right? An angle is the sum of its parts. So step 3 reason is angle addition postulate. The AAP. I should write that out because we're still not quite. Angle addition postulate. Now, can we introduce angle DBE the same way? What do we know about angle DBE? Arlene?
That angle CBE equals CBD plus DB.
Okay, and I want to put DBE first because if you'll notice, we have angle CBD in our top equation, also our first equation. I can also keep this as the same step because it has the same reason, right? If you put step 4, fine, but you can keep them both under step 3 because the reason's the same. Okay. Okay, we're gonna pause here. Anybody lost?
Yes.
Okay, Damien, are you lost just in this step or did you get lost before?
Well, I was lost in this step.
Okay, so that's good. All right. What we did was we realized that ABC and DBE have to be a part of this proof, right? Because that's what we have to prove are congruent. So we said, how can we introduce ABC? What do we know about ABC? And we said that angle ABC, which is this angle here, right? If we add that to CBD, so we take these two angles together, it equals ABD, right? We did the same thing, the same logic with angle DBE, which is the other one we have to bring into the party, right? DBE plus angle CBD equals the other angle that we had labeled as a right angle, CBE, right? This angle plus this angle equals the whole angle, essentially. Okay? Our brains work better when we're sitting flat, so let's try that. Anybody else? Anybody else? Jack, questions? Go ahead. Yep. It's a lot easier when we're kind of walking through it together and I'm explaining it as we go along than doing it solo. But where are you? You feel like you wouldn't know to come up with this? Like you wouldn't think to do this?
Yes.
Yes. So the trick of the proof is like, how can I introduce ABC? What do I know about ABC? Now there are no measures given, right? Except for what we're told are right angles, and so just look for anything. I know that this all started because Max said I know ABC is a part of ABD, right? And from there we said, okay, how can we work that into a mathematical postulate theorem or whatever? And we said, well, ABC is a part of it. CBD is the other part. Therefore, that whole angle EBD will be the sum of its parts, ABC and CBD, and that's where the right angle or the angle addition postulate comes from. Okay, it takes practice, right? It takes practice, but it's the ability to recognize, what can I conclude from the diagram? It takes practice. I'm sure you aren't the only one. Ellen. Arlene.
I think I have to answer for the next step.
Okay, let's save that for right now. Let's make sure that we're all. Catherine.
I have two things. How do you just like know what the next step is?
Well, because we're working toward this statement here. And so our next step should be setting up some sort of equation that's going to include ABC and DBE on opposite sides, right? Because eventually we want to work down to ABC by itself is congruent to DBE by itself. So we're setting up these equations, right? And so we're working toward getting ABC congruent to DBE.
So do you just have to like start with like everything like your group thing and then just like slowly work it in?
Exactly.
How do you like know?
Practice. No, seriously. You know, it's like when you were first learning to tie your shoes. You were probably shown, right? And then it's like, okay, like you knew how to do it because you were shown, but then after doing it yourself, it takes practice. You know, when you're at any sort of sports camp and you're shown a new move or whatever, it's like, okay, I see you do it. All right, I kind of get, but how do I exactly do it myself? It takes practice. Okay? Bryn.
Like when we do them by ourselves, some of them are gonna turn out differently than other people.
Potentially, like your path might be different, but your end result should be the same. Okay. Yep. Christopher.
Are we ever gonna get like a no solution, like until we prove something that's false?
Not for me. No. Claire.
How do you know like which like rule it is? Like
And again, that comes with the practice, right? This started. I'm glad that how we came up with this. Max just said ABC is a part of ABD. And what he did was smart because we already knew something about ABD, right? We already had something about that. And so noticing that ABC, what we wanted to introduce, was a part of something we already had, we said, well, how can we work with that? Well, ABD is that part plus another angle. Okay, so it wasn't even, Max just didn't put it out there. He got the conversation started with, I know this is a part of something else, and then we worked with it to get the geometric mathematical reasoning behind it. Okay? Liesel. Yes and no. Like we couldn't put where we're headed with this. We couldn't go there without this, and you'll see why shortly. Like we had to establish this before we're going to do what we're going to do now. Okay, so yes and no. Kind of like solving an equation, right? There's an order that you kind of have to do things, but sometimes you can switch it up depending on what it is, and that's a similar thing here. Okay, last one, Jack.
How do you know when like you're ready to say like, oh, this is why?
How do you know when you're ready for the proving statement?
Yeah, like, you could tell say it at any point.
Not really, right? Because we couldn't say it here because right now we don't have a single equation that includes both ABC and DBE together. We've got one equation with ABC, right? We've got a second equation with DBE, but we need something that's got ABC and DBE together to come up with this final statement.
I get that, but I mean, like you already know the answer technically.
Mocking me? Mocking me right now?
No, I'm
Yes,
Mocking me?
No, I'm actually serious. You have to practice.
Okay. So let's see where Arlene wants to take us next. Okay, and maybe some of these questions will become answered. Right? Let's just give it a shot. Arlene, where are we going next?
Number 4 is angle ABC is congruent to angle DBE because of the substitution property, and I know that too.
You jumped. You skipped a step here. Okay. Hold up. Shh. So her idea was that ABC is congruent to DBE because of the substitution property. Arlene, what are you replacing to get that equation? Because the substitution property means you're replacing something with something else, replacing something with an equivalent value. What are you replacing to get ABC and DBE together alone on opposite sides of the equation? So to use substitution, that means you're replacing something with an equivalent value. Damien, warning for you. Turn around, please. Okay? What are you substituting to get ABC is congruent to DBE?
Well, I know that angle ABD is congruent to CBE.
Yep.
And so then ABC must be the same as DBE. Would that be transitive then?
Not quite, because the problem that we have here is this CBD. We have to get rid of that first. Okay? Let's go another direction. Claire, what do you think?
Is it angle ABC plus angle CBD equals angle DBE plus CBD?
Excellent. Okay? Excellent. These two angles are congruent. Right? We've established that. Shh, hold up. Okay? These two angles are congruent. We've established that, right? So because they are congruent, and because ABD is congruent to angle ABC plus CBD, I'm going to, in my next step, I'm going to switch what you said slightly. You're heading in the very right direction. We can't get there directly. I'm going to replace CBE with ABD, okay? And say that angle ABD is equal to angle DBE plus angle CBD.
Why do we have to?
Okay? What I did, all right, again, just recapping here. I know that ABD and CB are congruent, right? We're all following there?
Yeah.
Okay. Which means that if CBE equals DBE plus CBD, then ABD must also equal DBE plus CBD. I'll say it again. I'll say it slower. We understand that ABD is congruent to CBE, yes? Okay, which means that if CBE is congruent to DBE plus CBD, then ABD must also be congruent to DBE plus CBD. We've substituted ABD in for CBE.
I was just going to say that.
Okay?
Oh yeah.
Is that what you said?
I was going to say that one is substitution.
Yes, this is substitution. The one thing that we replaced, we replaced CBE with ABD. We can do that because they're congruent. We noted that in step 2. Okay? Everything else stayed the same. Brandon, you have a question?
So that also means that angle CBE equals ABC plus CBD.
It would, and that could be a potential fourth step instead of what we wrote. That'd be an example of can you go a different route and end up with the same answer. We don't have to establish that here because of what we just did, but that is true also. We just don't have to say it. Alex.
So going off what Claire said, could you do
We wonder why we have so many questions about things that are going on up here. It's because we just need to focus on what's happening. I'm sorry, Alex. Go ahead.
So what Claire said, the angle ABC plus CBD equals angle DBE plus angle CBD.
Yes.
Would that be a thing of substitution?
Yes. That's going to be our next step. I want to make sure that we're all good with step 4 first, though. But yes, that's where we're headed. Kylie.
Why wasn't that there in step 4? Is saying
Because we have to, because now what we have, I'll highlight in black here. We have ABD equal to two different things, right? By stating that ABD is equal to DBE plus CBD, our next step, as Alex said, is in step 5, ABD is equal to both of these things, therefore, angle ABC plus angle CBD is equal to angle DBE plus angle CBD. Remember I said earlier, we need to get an equation that has ABC and DBE on opposite sides? That's what we've just done here, right? We have just been able to say because ABD has been set congruent or equal to these two expressions, it means they're equal to each other. This would be transitive. And so we now have an equation that relates ABC to DBE. Ellen.
So why couldn't that be our step 4 then?
Be-
Because if we already know like ABD and CBD are equal, and then those things that are equal.
It's taking one too many leaps. Okay? Proofs have to be annoyingly specific. And I apologize for that. But don't hate me. Hate. Okay. Well,
Confused how you found number 4.
number 4. So number 4 was we knew that ABD was congruent to CBE, right? And so because CBE, whatever CBE is equal to, ABD is also equal to, because they're congruent, right? So I replaced CBE with ABD with the intention of getting this situation right here. ABD equal to two different things, because that makes those two different things equal to each other because of the transitive property. Okay, so step 4 was all about, I already knew that ABD was equal to something. What else is ABD equal to? So I can set those two things equal to each other that I did in step 5. Okay? Bryn,
Oh, I know the last thing. Or the next.
anything more with step 5 here? Joey, question? Who invented proofs? Gosh, I don't know. Let's blame the Greeks. Socrates, Pythagoras, you know. I don't want you to look it up. I want you to miss the next step here. Okay? Bryn, what do you suppose the next step is? Shh. Folks. So Bryn's saying that we're at the point where we can say that angle ABC is equal to angle DBE. Why is that, Bryn? Not transitive property. What did you do, basically? So to get from the equation that we, what's that? Not substitution. What did you do? Like your next statement here, you said angle ABC is equal to angle DBE. How's that different from the equation that's right above it? Yes, you took away angle CBD from both sides of the equation, did you not? What property allows us to take something away? It's the subtraction property. The subtraction property allows you to take something away from both sides of the equation. Because angle CBD was on both sides of the equal sign, we can subtract CBD from both sides and get rid of it. Right? So because of the subtraction property, allows us to get rid of CBD, and we now have ABC and DBE on opposite sides equal sign, which is what we wanted. Okay? Now, are we done?
Yes, we are. No,
We're not done.
Greeks are horrible because they're not.
They're not.
Okay? Noah, why are we not done yet? Okay. Hold on. Okay, before we go on. Catherine, go ahead. Christopher, pay attention. Because the same thing was congruent to two different things. So we put those two different things equal to each other. ABD was equal to both ABC and CBD and DBD plus CBD. So we put those two different things, those two expressions, equal to each other. That's what the transitive property is. ABD was equal to ABC plus CBD. ABD was also equal to DBE plus CBD. Therefore, ABC plus CBD equaled DBE plus CBD, right? Here's our angle ADB here. The two things that are the same. Follow me? Each ABD equaled something different, B and C. That's what I have the expressions here. If that's true, the transitive property says that those two different things, these expressions over here, will be equal to each other, which is what we wrote in step 5. We have to include CBD because there's nothing that tells us we can take it away yet. We can't use the subtraction property prior to this because the subtraction property only works when we have the same thing on both sides of the equation. We had to write one equation with CBD on both sides in order to be able to subtract CBD from both sides. Okay? Noah says we're not done yet because there's one tiny little difference between our proving statements and what we currently have. The proving statement says these need to be congruent. Where we are says they're equal. And you don't know this property yet. It'll come up later on with triangles, but it comes up here. Our final step, we can say that ABC is congruent to DBE because it is the definition of congruency. The definition of congruency is that things are equal, okay? And so we can say that they are. We have written equal. We can switch it to congruent because of the definition of congruency. Damien.
You could also just draw a squiggly line.
No. Okay. There you are. Right? Hopefully you're able to make more connections between how we got from beginning to end than you were yesterday, just more practice. Hopefully you maybe recognized a few things along the way. I want you to attempt the final proof on the page.
Can you check mine?
I want you to attempt.
Can you check mine?
I don't even know where to start.
Start with the given.
And with the proof.
Anthony knows what's up. Okay. This will be due on Monday because tomorrow is a retake day. Okay. But see what you can do. Plan on a test next week, Wednesday or Thursday. What was the word? Test. Well done. I will not give you the book assignment. I was going to give you that. I can tell you what it was going to be. There was a book assignment. Remember I said that I've got multiple proofs to give you. We'll see how it goes. Oh, well then you can't comment. Claire.
Like the first step on the other one, could it be M is half of the line or the segment? Or do I have to
M is the midpoint of because of the definition of a midpoint. Well, no, hold on. Let me see what it says. Any more questions on this before I go down to the bottom one? Hold on. Okay. Starting this one, we're going to start with the given statement. And here's the trick on where to go next. Okay, here's the trick on where to go next. So Aiden, Will, whoever else asked, okay? Whenever you are given a term or a definition in a given statement, we are told that M is the midpoint of AB. Okay? Your next step should be, okay, what does that mean? Right? What does that mean? We have our statements and our reason. The first one is always the given. Because that given statement contained a vocab term, it contained a term. Our second step, what does that mean? We want to know what is the definition of a midpoint. Okay? Whatever your second statement is, your reason is going to be the definition of a midpoint. What does the midpoint mean? Right? Based on that, what does it tell us about the segment up here? That's all I'm going to say. You got to kind of take it from there. But I'm giving you your second reason. Your second reason is definition of a midpoint. Right? Okay. Notebook assignment, because you got me. That's how you math.
Don't forget to like and